Hey guys, so I'm doing the kidney's ability to conserve water, which is chapter 32.5, pages 682 to 685, if you wanted to follow along. But also I made a PowerPoint, which is in the submission, if you wanted to follow along on that. So we're just gonna get right into this. Also, I'm going to apologize. I don't know how to pronounce some of these words, so just bear with me on that. So insight to the kidneys. Kidneys are filters that remove most of what is in your blood and then pulls back what it wants to keep before sent to the bladder. They are not just a strainer leaving behind a giant mess, believe it or not, nor is it as simple as water going in and urine coming out, which is actually kind of what I thought it did. I didn't think it was this complex, but believe it or not, I learned that I was wrong. So I put a little picture of a nephron, which we'll learn about in the next slide. This is basically just something that it helps filter the blood, or they are what filter the blood. And then yeah, we'll just go ahead and go to that next slide. So entering into the kidney are the renal arteries that branch into tiny capillaries or nephrons. I'm really hoping I'm saying that right. But again, like I said, nephrons are what filter the blood, and they regulate chemical concentrations and produce urine. So as you look into the kidney, you have like different layers. I think that was talked about in the chapter before me, or the section before me, but yeah, so you have different layers of the kidneys, and then when you look into that kidney, you have the renal arteries that branch into tiny capillaries, nephrons. Anyway, so you have the filtration process, which you have three main steps of how blood filters into urine. So the first step is the filtration process. That consists of the proximal tubule. Then you have the tubular reabsorption, and this consists of the descending limb of the loop of Henle and the ascending limb of the loop of Henle. Don't know if I'm saying those right, but anyway, so then we have the tubular secretion, and this consists of the distal tube and the collecting duct. And we will learn about those in the next slide. So the proximal tubule, actually this is a picture of a nephron, and the proximal tubule, which you can see in the number 1, is so what happens in here is reabsorption, and the proximal tubule is critical for the recapture for necessary ions, water molecules, and nutrients. We're basically doing the first step of filtrating this blood. Salt is reabsorbed by active transport. Other essential nutrients are also reabsorbed from the filtrate into the interstitials, to that fluid, which is then transported to the loop of Henle. So we go into the descending limb, which is that entire first little, I guess, descending limb looking thing, but it doesn't go into that little divot. So this portion, the filtrate loses water and increases in salt concentration because of the increasing osmolarity by actively pumping out salts to allow water to flow out by osmosis. So yeah, it's basically self-explanatory. You're just increasing that salt concentration and allowing that water to get out. So then we move into the ascending loop of Henle, which is unlike the descending loop. The ascending lacks water channels, which is impermeable to water. However, once the filtrate enters the thin segment, which is, as if you look at like the picture, the diagram, like you can see like that thin little segment. But yeah, once it enters that, it's impermeable to water. However, once the filtrate enters that, once that filtrate enters the thin segment of this loop, salt diffuses out of the tubule to help maintain osmolarity. So like you can see the NaCl getting out of the, diffusing out of the tubule to help maintain all the water that was lost in the descending limb. So then we go into the distal tubule, which is that other spiral flowy tube, which is officially where urine is created, I guess. So this is where the pH regulation is contributed by the secretion of hydrogen ions and HCO3 reabsorption. So you can see the ions coming into it and the HCO3 going out, and it's just basically like this whole what's the word for that? Equilibrium, there we go, equilibrium type thing where it just keeps it regulated. So then we go into the collecting duct, and this is where the filtrate becomes concentrated by losing more water by osmosis, which allows the duct to become permeable to urea. Then urea escapes the urine and travels back to the ascending tubule, and just makes this whole big cycle and kind of makes its way back around. Okay, so then I just kind of put like a little fact in here. The kidney can excrete urine up to 4 times as concentrated as the osmolarity of blood that's in the mammal's body. So a vocab word that I read up on was the counter current multiplier system, which is basically that entire system that we just went over in that last slide. It's a process of using energy to generate an osmotic gradient that enables you to reabsorb water from the tubular fluid and produce concentrated urine. The countercurrent system of the loop of Henle involves active transport and thus an expenditure of energy. Next, I have the evolution of kidneys. So just different ways kidneys have adapted and helped animals in their various habitats. For example, in desert animals, these mammals have low availability to water, so they excrete small volumes of hyperosmotic urine with minimal water loss, so they can keep that water in their bodies longer since they don't have much available to them. Then we have aquatic animals. These mammals have high availability to water and low availability to salt. Therefore, the kidney can produce large volumes of hypoosmotic urine, getting rid of the excess water with little salt loss. Okay, then I just put a video of a crash course in case none of this makes sense to you, because this video made total sense to me and just kind of helped explain the process a little bit better than what I'm probably doing for you. And then I have my sources. So hope that did not just completely blow your mind of kidneys are not just a simple process of water coming in and urine coming out. All right, thanks guys, bye.